Next one will be Helena Domínguez Sánchez. Please start the recording.
Hello, everybody. My name is Helena Domínguez Sánchez, and I work in the Institute of Space Sciences in Barcelona. Today, I'm going to talk about tidal stream detection in HSC with deep learning. This is a project that kicked off during the Kavli summer program in astrophysics, and so far has counted with a valuable contribution of many collaborators. Tidal streams are important because their frequency and characteristics can be used to disentangle different formation scenarios, such as in situ star formation versus accreted stars. In principle, this should be an easy task for the CNN because it's a classical cat and dog problem. Is there or is there not a tidal stream? However, tidal streams are difficult to detect. They are rare because they last only a few dynamical periods, and they're faint because they leave their imprints in the outskirts of galaxies. Therefore, we need deep imaging and large areas, and so far, very small training samples are available. A pioneer attempt was done by Walmsley in 2019, but the authors only had 300 galaxies labeled as tidal streams. In this project, we're using HSC data, which reaches 26 magnitude over 1400 square degrees. We are making use of the Cataphone catalog, which uses a filtering algorithm to detect high special frequency features, plus a visual inspection. And there are 1,200 galaxies which show tidal features out of 20,000. We are using this sample as a training sample, and after playing with some hyperparameter optimization and image preprocessing, you can see here how these hyperparameters can affect the overall accuracy. In this panel, I show the outcome of one of the models. In red are galaxies classified as non-tidal streams, and in blue, galaxies which show some tidal stream features. When we use an unbalanced sample, the overall accuracy is very large because the fraction of tidal streams is very low. But when you use a balanced sample, this accuracy drops. And although the precision, the purity is pretty large because you can construct a very pure sample when making a cut at around 0.6. But this is at the cost of having a very low completeness because you miss all the galaxies with low probability values. One of the problems that we found is that it's not obvious what a tidal stream is. Besides the Cataphone catalog, we also had 4 classifiers visually inspecting the 20,000 galaxies. And we found that for galaxies which were classified as tidal stream by the 4 classifiers are only a 16% of galaxies which were classified as tidal streams, at least by 1 classifier. Good news is that these galaxies show a higher probability of having tidal features by our models. And we also checked that the false positives, that I saw here some examples, show some features which are difficult to distinguish from real tidal features. So we are in the right way. But there's still a lot of room for improvement. So far, we have realized that automated detection of tidal features is a challenging task due to different reasons. First, the low number of real tidal stream detections, which makes us have very small training samples, but also because of the subjectivity of what a tidal stream identification is and the subtleness of these tidal features. As part of the future work, we plan to play with the neural network architecture to use more complex or modern output architectures. And we also plan to use transfer learning, like applying models trained on the SDSS for bar detection, as well as to combine different observational data sets or even rely on simulations. So if you have data sets or ideas that can be useful for this project, please contact me. I'm open to collaboration. Thank you.